Hey everybody, we're going to go ahead and get started. Today we're going to be talking about AC compressors, where all the magic starts as far as I'm concerned. So let's get started. I'm going to start up with a PowerPoint. I'm going to share this with you like we always do. All right, folks, we're going to get going. All right, today I want to kind of just cover a little bit about AC compressors. This is going to be the AC compressors kind of common. There's some other configurations and we'll share that as they come along. I will be putting together a presentation on future technologies of air conditioning as we go as we get to the end of the class. So well, I like to take, you always see the adjectives or something. I like to consider them talking points. So when I talk about certain subjects, I want you to get something out of it, basically what I'm trying to say. So one of the things that I try to do in this class is get you prepped for the 609 that I keep on talking about. And also, I would really like for you to consider taking the ASE heating and air conditioning certification, which is the A7. Now, this can actually help you get into another end, which would be more on the heavy duty side. And this would get you that stepping stone, because you can go and get your H7, for your buses and stuff like that, or you can get like your T7, which would also get you into truck air conditioning. This will help you again when you start taking classes like the transportation refrigeration that we have at the college. So these are kind of little stepping stones, and it'll help you a lot along the way. So we're going to state some of the different types of compressors that they're being used in automobiles. Some of the compressors too, believe it or not, are used in some buses as we go along too. So I'll try to point out some of that as we go. Some other things I want to talk about, some of the parts inside the AC compressors, and also in the compressor clutches and all that are on the most common type things, common automobiles and so later. So there also talk about the valves and switches that are involved in them, and we'll start talking about how do we diagnose this. And I'm going to put together a whole video on just diagnosing AC compressors, some of the most common things, and what kind of strategies you should think about taking on when you want to, really diagnose the AC compressor and how try to help you out a little bit. That's what I'm trying to say. So when we started off with AC compressors, we had piston type compressors. Piston type compressors were very common. They took a lot of energy. I want to say that. And so most of the older vehicles had a piston kind of compressor that was very, very similar to a gasoline engine, and almost like a lawnmower type engine, bigger than that, but kind of the same thing. So they were similar to smaller gasoline engines and reciprocal type piston types. Newer type piston compressors use a swash or a wobble type plate, and we'll get you into that in just a little bit. We've got a little bit of animation. Hopefully it'll come through so you can see that also. And then vane compressors. Vane compressors has vanes. So the vane compressor has vanes that contact the rotor housing at each end, and they slide to make a seal at the end, each end of the actual rotor turn, as the rotor turns. I'll kind of give you a little bit when I get to that picture. I'll show you kind of something that looks very similar, and we'll get into that too. So scroll type compressors requires that you rather complex machining to achieve constant seal between the fixed and the movable type parts. So piston type compressors, they have a piston to them. I got a picture for you in just a second here, and they are very basic. Like we said before, they're almost like a small little engine, which really they are. But we're using the pistons to compress, just like we're doing with the other compressors too. But we're using these as a straight type compressor. So if you look at this, you can see that the compressor, gosh, this sure looks like an engine to me, Marty. So here we have a compressor, and it goes down. The one difference that you're going to see on this particular compressor versus an engine is, wait a minute, where are the valves, Marty? I remember that an engine has to have valves. Well, if you look at the piston as it's going down, you see this little piece of metal here. This is that is a valve. This is an actual valve. These are reed type valves, and they're one-way directional. So as the piston goes down, it's going to open up. It's going to actually open that reed valve. And then when you go back up, you can see that there's a reed valve over here, or a discharge valve. Sometimes they call it intake valve, exhaust valve. But instead of having that the complex type valve with the spring and the seats and all this, now it's a little bit less complicated. Now, this is very, very common on the old compressors. Now, some of the old compressors will actually be in a V shape too. So I'll have a twin dual compressor type like that. And, I should say a dual piston type compressor. So this is not uncommon that we had back in the day. Chrysler, Ford pretty much had their single compressors. I remember those going on. And it was the General Motors that had the radials, and some of the AMCs had the radials also. So these are very common. So vane compressors, they are different. And I have a nice little slide for you on the next page here. And basically, they just had almost like little swipers. One of the things that really, let's put it this way. One of the things it reminds me of is how an air gun works. When like a impact gun. This is very similar to the way, or if you take and me, I like to take things apart and figure out how they work. If you take an air gun apart, like an impact gun, you'll find little bitty vanes like this. And they kind of sweep around, bringing in the air, and that's what makes them move like that. So this is very, very much like the air, as far as I'm concerned, an air gun. So let's see if this guy will work. Oh, here we go. And this is exactly how we're doing it. So we're moving it around, squeezing it down, and pushing it on out. So it's coming in here from the evaporator. So remember the cycle, how it goes across. And then it brings into this cavity right here. And as it goes around for the cavity, it kind of squeezes it on down. So we bring it around, squeeze it on down, and then we go, boom, right to the compressor. Okay. So this is another style kind of compressor, the vane type compressor. The other types are what they call scroll type compressors. These I've seen quite a few on heavy equipment. It's very common. I don't know if I still have some, but I had some bigger scroll compressors over in the diesel area. There are some advantages and disadvantages to them. They operate, kind of funny. They are very machined. So if you look how closely they have to be machined to make them, and if you get a little bit of contaminant in there, and it gets trapped in there. It can stick. It can also cause, other things can happen too along the way. So let's see how if we have our animation, if it works on this particular one. So it kind of squishes around and boom, right up. So we got the inlet right over here. And then we take it in and we kind of squish it around until we get it down. So you can see how that can be very, it can be a problem, sometimes, especially when you get some stuff that is not supposed to be there. It's not gas. It's, maybe, some parts are starting to come apart and they flow through and cause it to have problems also. All right, this is a wobble plate type compressor. This is it works very, very well. You can turn on the compressor clutch and you can just keep it on going. And depending on the load of or the demand, I should say, of air conditioning, it will be a high pitch to the wobble plate, or it'll be almost a flat pitch to the wobble plate. So this what's really, these little compact variable type compressors. So that little plate that you have right here can move around, and it's controlled by a control valve. And here's the wobble plate for you. See how it moves around, and depending on what kind of a load you have, you can actually fix it to that position, and it's all done by controls. And it's very, very common too. I just want to say that also. So here it's going to show you again. Boom, boom. A little swash plate going back and forth. So you see how it kind of actually, and then we can have some multiple, pistons going around. So it's almost like having a piston here and a piston here to make that all work. And here is, a different type too. So see how it makes it a little bit, so now we have 1, 2, 3, 4 pistons going on. And I believe York is the one. Oh yeah, it is York. So that's kind of the basics of the different types of compressors that are out there. There's a little more complicated into them. We'll be breaking some compressors down in class to kind of, touchy-feely to see what they look like inside. The other thing I want to bring to your attention to is compressor clutches. Now, compressor clutches is what starts the engagement part. Now, some compressors will use a clutch just to engage, and all the other magic goes inside, like your swash plate compressors. They'll change on the load value. Also, your different multiple angle compressors too, so they can actually change that camshaft stroke on the compressor to make the amount of load it is demand, or the cooling load. You can actually do it. You can actually change up as it needs to be. Now, so we have to have something that starts the whole process up. So the clutch coil is the magnetic clutch coil assembly. If you've taken electric classes, you know how magnetism works and all. But just kind of in a little bit of a nutshell, well, let's get to the next slide and I'll show you a little bit what I'm talking about here. So what we're going to do is we're going to have a plate. So this plate on the outside is actually going to engage with this pulley assembly. So this pulley assembly is where the belt is connected to. Now, I'm not going to really get into hybrid yet. We're just going to go with the basics, and when we go into our hybrid section, I'll get a little more into that part. So we'll have a disc on the outside. This is where going to be our engagement's going to be at. Here is going to be where the pulley that actually connects to the belt. And then we got some bearings that go with it, some clips, and then we also have a seal back inside here that we're not even really showing you, because we want to keep the refrigerant inside the compressor. We don't want the refrigerant to come out. So we actually have a seal down inside here. And then we have this guy here. This is a clutch field coil. This is going to build up magnetism. We're going to turn this guy on. We're going to turn our current onto it, and it's going to actually build up a magnetic field. And that magnetic field is going to pull this plate. Oops, I went a little too fast on this previous. It's going to pull this plate, slam it against here, this pulley, right? This pulley right here that has that belt onto it, and it's going to allow it to turn the compressor. So this guy right here, this actual clutch hub, is going to be connected to this shaft right here. This shaft is what's going to be turning the compressor. All right. So until this shaft connects, until this sandwiches up against that pulley, that is just going to be sitting there. And the actual pulley assembly here is going to be spinning with the belt. And then when we get that, movement, and then we get that magnetic field and magnetism pops that on there, that's when we're going to start seeing the compressor to start turning internally. And we've been doing magnetic clutches for a long time. There's some key things when we get into our diagnostic part of it. We're going to talk about how do we diagnose this actual clutch assembly. Okay, so it has to have enough current, it has to have enough voltage, but also there's some other key things too. So the spacing of that actual clutch hub to that actual clutch pulley. Okay, we'll get into that. So there's other things that are happening inside. There's switches going on. We have low pressure switches, high pressure switches, a lot of protection devices. We actually have where the clutch connectors to will have in most cases, we'll have something that will actually, if we have too much pressure going on, which can happen especially with our fans not working properly, we'll have a relief, a little calibrated valve that actually will relieve a refrigerant in case it gets too high, because we don't want to start blowing off hoses and destroying compressors and all in other parts along the way. But I wanted to show you again about this little clutch assembly. Okay, so this is that would be that clutch hub. I'm sorry, the clutch bearing assembly and the clutch part of the coil, magnetic coil. So here we actually have the clutch applied. Let's go ahead and do this again. So it's loose, and then we're going to turn it on, and then boom, we get that magnetic field going, and it's applied now. So out here, and then as soon as we turn it on, bam, comes right in, applies, and then we make that contact. All right, so different control, compressor, discharge, control switches. There can be control, the switches can be all over the place. So they can be on the compressor, they can be off the compressor, they can be in lines, they can be on the receiver dryer, they can be on an accumulator, and which is not uncommon. So there's different places you might find them. How do I find out where they're supposed to be? Well, there's lookup information for this also. So yes, if there's excessive high pressure produced by the compressor, they don't want to damage it. Well, by reasons, we don't want to damage the compressor and cause possible rupture, like I said earlier, of hoses, and possibly have a compressor damaged. So we do have different types of switches, and depending on the system you have, we could have a low pressure switch. If you get too low of actually refrigerant pressure, if we have too high refrigerant pressure, and we'll talk about why and how that happens. So depending on the system, you may have multiple switches, is what I'm trying to say. This is kind of similar to what I've been talking about. So this one actually has pressure switches on it. This one, I can't really tell what they are for yet. This is something that we would actually have to look and find out. This almost looks like a low pressure hose, but I don't want to say 100% it is or not. This is just showing a couple switches in place. So we have actually two on the same line, it looks like. Now, some vehicles, they will use a compressor speed or an RPM sensor. If it does not match the RPM of the engine, the actual motor, engine, the motor of the vehicle, they will actually consider that a slipping clutch, and it will shut everything down. And these are, I've seen more of them on the Acuras, Toyotas, a few of the Asian type vehicles. That's what I've seen them on, and it can, those switches can go bad. So you'll get it to where the compressor never comes on. We'll get more into that when we get into the diagnostic into this too, but this is some of the things that we look at. So the ECM is what's actually triggering the compressor. Okay, so if the ECM doesn't see that it's matching the RPM on the compressor, matching the RPM on the actual engine itself, it will shut things down. And then we have compressor, well, I really don't want to get too far into this. I'm going to save this for us to make sure we understand, get really deep into it. So I want to kind of stop this presentation at this part, and then we'll pick it up again. And I want to go a little bit deeper into the diagnostics as we go across. All right, folks. So this is just covering an overview of compressors and giving you the different styles that are out there. And then we'll get deeper into it as we go along. All right, look forward to the next video. Again, don't forget, you can reach me over through the Canvas inbox, my email, and you got all the information how to contact me. All right, we'll talk soon. Take care now. Bye.